Hi guys, hope you're fine and doing well. So today we will be discussing this problem from the LeetCode Biweekly contest, which is minimum bit flips to convert number. So this problem is pretty easy and it says that bit flip is an operation wherein we can change a bit if it is 0 to 1, and if it is 1 then we can change it to 0. So here an example is given wherein x is equal to 7 and its binary representation is as three ones. So if we want to like change the last bit, so we can do that, and the bit will be become to 0. So similarly, if we want to change the second bit from the right, then it can also be changed to 0. So this is what the bit flip means. So the question says that we are given two integers, start and goal. So we have to output the minimum number of bit flips or the operations that are required to convert start to a goal. So here I am taking first example. So the first example states that if we want to change 7 to 10, then what we will do is that we will write the binary representation of 7, which is three ones, and the binary representation of 10 is like mm, yes. So since we have to change 7 to 10, so the bits that we need to flip is the first bit, the second bit. So the first bit will be changed to 1, second bit will be changed to 0, third bit will remain as it is, and the last bit will also be changed to 0. So the total number of changes that we have done is 3. So this is the observation, and similarly we will be coding this logic. So let's make a function wherein I will return an array, and this function will contain an integer n, and the size of the array that I will be returning is of size 32, since the constraints are 10 raised to power 9, so it is an integer range only. So I'll take 32 bits, and what I will do is I'll create an integer I, and I'll store all the binary representation of this number in this array. So this is simple code for storing a number in an array in a binary form. And I'll simply return this array. So basically if we see here that we are just comparing the bits in 7 and 10. If any bit is equal, then there is, for example, like here, this bit is equal, so we are not required to do any operation. So we can leave it as it is. And in the other places, if the bits are not matching, then we can count the operation and increment it. So I'll create two arrays, A, and pass this start to the function, and similarly array B, and I'll pass goal integer also to the function. Now I'll create an count variable, and I'll simply iterate over all the indices of the array, and it should not be n, basically 32, because the length of the array is 32. And if a of I is not equal to b of I, then we will simply count plus plus and return count. So let's see if it is working. Yes, so it is accepted. So if you understood the solution and appreciate my work, you can give a thumbs up to this video and consider subscribing to my channel so that you don't miss any of the upcoming updates. So thank you and let's meet in the next video.